On June 24th, something is going to happen that the mainstream technology press has almost entirely ignored. Buried by Microsoft in technical documentation written for hardware manufacturers rather than human beings. And it will affect tens of millions of people who have never heard the term secure boot in their lives. For a significant portion of those people, that morning they will sit down at their computers and find that it simply refuses to start, not slower, not glitchier, not missing a feature they occasionally used. It will not boot. The operating system they chose, configured carefully, and depend on every single day, is going to hit a wall that Microsoft built. A wall that Microsoft is enforcing through a mechanism so deeply embedded in modern computer hardware that bypassing it requires technical knowledge most people do not have, and in some cases cannot be bypassed at all. Microsoft calls it a secure boot policy update. The Linux community calls it what it actually is, an existential threat to the ability of non-Microsoft operating systems to run on Microsoft-influenced hardware. And the date it goes fully into effect is June 24th. By the time this is over, you are going to understand exactly what secure boot is, what Microsoft is changing, why the timing of this change is not coincidental, who is affected, what the real consequences are, and exactly what you need to do right now, before a decision gets made for you by a corporation that has spent 40 years, ensuring that the answer to the question of which operating system you use is always, inevitably, unavoidably, Windows. Begin with a number, 32.8 million. That is the most conservative, credible estimate of the number of people worldwide who use Linux as their primary desktop operating system. That number has been accelerating sharply over the past 3 years, driven by dissatisfaction with Windows 11's forced hardware requirements, its mandatory Microsoft account setup, its aggressive AI feature rollout, and its escalating data collection practices. Add to that the many millions more who run Linux in a dual boot configuration alongside Windows for development work, privacy-sensitive tasks, or simply because they prefer the experience. The total population affected by what is implementing on June 24th is not a small community of hardcore technical enthusiasts operating at the margins of mainstream computing. It is a global population of ordinary people, students, developers, small business owners, researchers, writers, activists, and privacy-conscious individuals who made a deliberate choice to use software that respects their autonomy. They are about to discover that the hardware their software runs on is not as neutral as they assumed. To understand what is happening, you need to understand what secure boot actually is, because the name is doing significant political work, and understanding the mechanism beneath the name is essential for understanding why this particular change is so consequential. Secure boot is a feature of the UEFI firmware, the low-level software that runs on a computer's motherboard before any operating system loads. It was introduced as part of the UEFI specification in the early 2010s. And sold to the public and to regulators as a security feature. The stated purpose was to prevent malicious software from inserting itself into the boot process before the operating system loads a category of attack called a bootkit or rootkit that is genuinely dangerous and genuinely difficult to detect or remove. Secure boot addresses this by requiring that every piece of software involved in the boot process be cryptographically signed with a key that the firmware recognizes as trusted. If a piece of boot software is not signed with a recognized key, the firmware refuses to load it. The machine will not start. The problem that critics raised in 2012, when Secure Boot was first mandated for Windows 8 certification, and that has never gone away, is the question of who controls the keys. A cryptographic trust system is only as trustworthy as the institution that manages the root of trust. And in the case of Secure Boot on the overwhelming majority of personal computers sold in the world, that institution is Microsoft. Microsoft operates the Microsoft UEFI Certificate Authority, the organization that signs the keys that firmware trusts. When a hardware manufacturer ships a computer with Secure Boot enabled, they include Microsoft's Certificate Authority certificate in the firmware's trusted key database. Anything signed by Microsoft boots. Anything not signed by Microsoft does not. Linux distributions have historically navigated this environment through a mechanism called shim. Shim is a small bootloader signed by Microsoft's Certificate Authority that acts as an intermediary. It loads first because it carries Microsoft's signature, and then it verifies and loads the actual Linux bootloader using Linux's own keys. This chain of trust allowed Linux to boot on Secure Boot-enabled hardware without requiring users to disable Secure Boot entirely, and without requiring Microsoft to directly sign every Linux distribution. Shim was an engineering solution to a political problem, and it worked imperfectly, with ongoing maintenance overhead, for over a decade. The critical fragility in that arrangement was always this: Linux's ability to run on modern hardware has always depended on Microsoft continuing to recognize the shim signatures. That dependency is precisely what June 24th exploits. What Microsoft is implementing is a new secure boot policy layer referred to in its technical documentation as Secure Boot Advanced Targeting, or SBAT, an additional revocation mechanism capable of blocking specific versions of shim and other boot components. even if those components carry valid cryptographic signatures. The specific action on June 24th, Microsoft is pushing through Windows Update a revocation list that includes the shim versions the overwhelming majority of currently installed Linux distributions depend on to boot. When that revocation list lands on machines that have Windows installed alongside Linux, the firmware refuses to load the affected shim versions. The Linux boot process fails. The machine displays an error. And for users who do not understand what happened, the experience will be indistinguishable from their computer simply breaking. Microsoft will tell you and has told the Linux community in response to the backlash that erupted when developers first analyzed the implications that this is a security update, that the shim versions being revoked have known vulnerabilities, that the SBAT revocation mechanism is technically sound. And here is the honest truth about that argument. It is not entirely wrong. Some of the shim versions being targeted do have documented security issues. Boot security is a real concern, but the implementation of this change tells you something important about whose security Microsoft is primarily concerned with. If Microsoft's genuine priority were boot security across all operating systems running on Windows-certified hardware, the company would have coordinated with Linux distribution maintainers months in advance to ensure updated shim versions were deployed before the revocation list went live. It would have built detection into the Windows update process to identify dual boot configurations and warn users before applying changes that would break their Linux installation. It would have provided clear, prominent, plain language notification to users of affected systems explaining what was changing and what they needed to do. Microsoft did none of these things. The Linux community learned about the June 24th deadline not from Microsoft communications, but from developers who read firmware specification documents and update manifests and reverse engineered the timeline themselves. The people most affected by this change are the last people Microsoft told about it. Linux is the primary alternative to Windows on personal computer hardware. It is growing. Microsoft's market share is the thing that grows when Linux's does not. The mechanism being used happens to be a security mechanism, but the effect of the change is to make Linux harder to run on hardware Microsoft influences. The specific implementation choices Microsoft made: no advanced coordination with Linux maintainers, no dual boot detection in Windows Update, no plain language user notification guaranteed maximum disruption to existing Linux users. That is not what security prioritization looks like. That is what competitive prioritization looks like. Now, who is specifically affected because the impact is not uniform? If you run Linux exclusively with Secure Boot already disabled, you are not directly affected by the June 24th update since the SBAT revocation list is delivered through Windows Update and your machine has no Windows installation. However, the revocation list can propagate to firmware on machines that previously ran Windows even after Windows is removed, worth monitoring closely. If you run Linux in a dual boot configuration with Windows on the same machine, you are in the highest risk category. Windows Update is running. The SBAT revocation list will be delivered on or around June 24th. If your Linux distribution uses a shim version on the revocation list, your Linux installation will fail to boot after the update. This is the scenario affecting the largest number of people and the one requiring the most urgent attention. If you are a developer or system administrator managing Linux deployments in environments where Windows is also present, the implications extend beyond your personal machine to every system in your environment. Here is exactly what you need to do, starting right now, before June 24th arrives. Step 1. Determine whether your Linux distribution uses a shim version affected by the revocation list. The specific shim versions being revoked are documented in a public GitHub repository maintained by the Linux shim development team. Ubuntu, Fedora, Debian, Mint, Arch, and Manjaro have all published security advisories in recent weeks. Check your distribution's official forums and security advisory pages for a post specifically addressing the June 24th SBAT update. If your distribution has released an updated shim package that is not on the revocation list, installing that update before June 24th is the single most important action you can take. Step 2. Back up everything on your Linux installation right now, today, before anything else. Use your distribution's backup tools or a live USB environment running a tool like Clonazilla to create a complete image of your Linux partition. Store this on an external drive that you disconnect and physically set aside. If the worst happens on June 24th, having a current backup means you lose hours of recovery time rather than losing data. Step 3. Document your current firmware settings before anything changes. Restart your machine now and enter your UEFI firmware setup, typically accessed by pressing F2, F12, delete, or escape during startup depending on your hardware manufacturer. Navigate to the Secure Boot settings and write down or photograph exactly what you see. Which Secure Boot mode is active? What keys are enrolled? Whether there is a custom key option. This information is your reference point if you need to perform manual recovery. Step 4. Temporarily pause Windows Update to give yourself time to implement the other steps without the revocation list landing before you are ready. Go to Windows Settings, gives Windows Update, gives Advanced Options, gives Pause Updates, and set the maximum available pause duration. Once you have confirmed your Linux installation has an updated shim, you can resume updates. Step 5 applies to users whose Linux distributions have not yet released an updated shim. You have two options. Option A. Disable Secure Boot entirely in your firmware settings, which allows Linux to boot without any shim verification chain at all. For personal computers not operating in high-security enterprise environments, the practical security impact is modest, and the alternative, a non-booting Linux installation, is worse. Option B. More technically complex, but more time-preserving. Enroll your own machine owner key in the firmware and sign your Linux bootloader with that key using the Mochatil command line tool. The process takes approximately 30 minutes and is documented in detail on the Arch Linux wiki and the Ubuntu community documentation. Step 6 covers recovery if you discover on or after June 24th that your Linux installation no longer boots. Boot from a Linux Live USB, which carries its own boot environment independent of the revocation list issue. From the live environment, access your installed Linux partition, update the shim package if an updated version is now available, reinstall the bootloader, and restore boot functionality. Distribution-specific guides will be available across all major community forums. By June 24th, from users who have already tested the recovery process, you will not be alone in navigating this, and the documentation will be there when you need it. None of these 6 steps are beyond the capability of anyone who installed Linux in the first place. None of them require expertise beyond what you already demonstrated when you chose to run a non-Microsoft operating system on your hardware. What they require is time, attention, and the awareness that a deadline is coming that will not wait for you to get around to it. There is a longer conversation that this moment demands, one that goes beyond the technical specifics of shim and SBAT and revocation lists. Secure Boot, as implemented on personal computer hardware, answers the question of who controls your machine the same way every time. Microsoft controls the root certificate. Microsoft controls what gets signed. Microsoft controls what gets revoked. Microsoft controls the timeline, the communication, and the implementation choices that determine how that control is exercised. Microsoft can make a decision, in Redmond, Washington, push it through a Windows Update mechanism on hundreds of millions of machines simultaneously, and render the Linux installations of tens of millions of people non-functional without asking permission, without providing meaningful advance notice to affected users, and without bearing any of the consequences those users will face when they sit down on the morning of June 25th and find that something they built, configured, and chose is simply gone. That is what control over the boot layer means in practice. It means that the fundamental question of whether your computer starts is not answered by you. It is answered by Microsoft. The long-term structural solution is not a settings change or a shim update. It is hardware that is genuinely open, firmware that is community-controlled, and boot security mechanisms that do not root trust through a single corporate certificate authority with its own competitive interests in the operating system market. Projects like Coreboot, LibreBoot, and the work being done by the open firmware community point toward that future. They are not mainstream yet. They require technical sophistication most users do not have. But the events of June 24th are exactly the kind of concrete demonstration that moves projects from niche to necessary. Critics warned in 2012 that giving any single company control over the boot layer of the world's personal computers was a decision whose consequences would eventually be felt. For most of that decade, the fight looked like paranoia to casual observers. June 24th is the moment the theoretical becomes concrete, the moment that validates a decade of warnings from developers and freedom advocates and security researchers whose arguments were written in technical language for technical audiences, and that most people never heard. Those consequences are being felt now. The exodus does not have to be your story, but it will be the story of every Linux user who did not know this was coming and did not act before it arrived. You know now. Your system, your files, and your freedom to choose your own operating system are worth 30 minutes of your evening.